Greetings and good day, everyone. For our group's energy analysis, Federici and I were responsible for the groundwork, the physical audit of the FPTT building. To be honest, this was a very tiring and physically demanding process. We did not just look at a map, we walked every single floor, opened every lab door, classroom, and inspected the administration offices to define our audit boundaries. We wanted to make sure that our scope was 100% accurate, covering everything from the massive lecture halls down to the smallest shared student spaces. During this walk, things got a bit confusing. We had to manage a massive inventory of equipment, but we managed to stay focused by identifying the significant energy users, or SEUs, based on the UNIDO framework. As you can see on the slide, we categorize this into three main groups. First, the HVAC systems. These are the primary energy drivers. We're talking about the centralized cooling for the halls and the split units in staff offices. Second, the lighting load. We mapped out the transition from old T8 fluorescent tubes to newer LEDs. And third, the ICT and plug loads. This includes the high density computer labs and those always on appliances like water dispensers. One of our biggest realizations was the presence of energy vampires, devices left running during off peak hours that slowly drain the faculty's budget. By identifying these boundaries and equipment, we established a solid energy baseline. This is this was the essential foundation that followed us to move from just looking at a building to actually analyzing its energy behavior. Now I pass it on to Ferici.
Hi, my name is Fergie Zongonica and my model number B0624103882. First, we go to the trend and peak usage. So, our analysis shows that energy use follow the economic calendar, hitting a peak of 14,000 kW per hour in October due intensive lab work. Conversely, usage dropped to the lowest point at 8,500 kW per hour in December during year-end break. Next, we go to the significant energy users. So, the primary driver is the HVAC system rated at 40 kW and consuming over 160,000 kW per hour annually. Lighting and computer lab also contribute significantly to our daily basis during work hour. So, the good news is that this system offer up to 30% improvement potential. By targeting these high impact areas, we can drastically reduce both operational costs and our environmental footprint. We have established three energy performance indicators to measure our success, specifically targeting a 25% reduction in energy intensity and monthly cost per user. So, as a result, we can drop usage per student from 450 to 337 kW per hour. So, we can maintain academic quality with less energy in terms of saving opportunities. Our most effective strategy is HVAC optimization. We save 12,614 ringgit annually. Furthermore, LED lighting are highly valuable as they pay themselves in under 2 years. Finally, we can recommend switch of awareness campaign for immediate 6-month payback. Overall, this measure achieved a massive energy reduction without affecting student comfort.
Good day, Doctor. I'm Yashbin Kanesan. I present the financial assessment. HAVC optimization delivered the stronger financial performance with a payback period of only 0.40 years, a very high IRR 195%, and the highest net present value of RM 42,880 is provide extremely fast cost recovery and significant long-term saving despite its low investment cost. The LED lighting retrofit ranks second in financial performance, Although the initial investment is higher at RM 50,000, it's achieved a payback period of less than 2 years and a positive MPV of RM 16,138. They indicate strong medium-term profitability and consistent saving throughout the project of lifespan. The awareness campaign also shows strong financial efficiency. With minimal investment is achieve a payback period of just over half a year and a high IRR of 85%. This demonstrates that behavioral measure can produce meaningful financial return when combined the technical solution. Overall, these three measures clearly strong financial and should be prioritized. That's all from me. Thank you.
A good day to everyone. I'm Tarshi Ganitsan and will continue with financial assessment part. In comparison, computer lab power management provides moderate financial returns with a payback period of about 1 year and IRR of 62%. It is financially viable but delivers lower absolute savings compared to HVAC optimization and LED retrofitting. On the other hand, the vending machine upgrades performs poorly in financial terms. It has the longest payback period of more than 7 years, a negative net present value, and an IRR close to the discount rate. That indicates that it is not financially attractive and should not be prioritized based on the monetary returns alone. Next, based on payback period, net present value, and internal rate of return, HVAC optimization should be implemented first due to its extremely high return and very short payback period. LED retrofitting should follow as a medium-term investment with strong and stable savings. Awareness campaigns should be implemented alongside technical measures because they require minimum cost while reinforcing long-term energy savings behavior. This balanced approach ensures maximum financial efficiency and supports sustainable energy management at FPTT. That's all from me. Thank you.
My name is Nuraimati Zamri and I will explain about social responsibility and sustainability. The proposed energy management improvement measure in the FPTT building are not only aimed at reducing electric consumption, but also at creating a culture of more responsible energy consumption among students and staff. The implementation of LED lighting with presence sensor and the optimization of the air conditioning system help to improve energy efficiency, user comfort, and reduce energy waste that impacts the environment. The initiative is in line with the United Nations Sustainable Development Goals, specifically SDG 7 regarding energy efficiency, SDG 12 regarding responsibility consumption, and SED 13, which emphasizing action of climate change. In addition, an awareness campaign, FPTT Safe Energy, Sustainable Future, is proposed to increase awareness among the campus community through poster, digital reminder, and daily practice such as turning off electric appliances after use. Overall, this approach is expected to not only reduce operating costs but also make FPTT an example of a faculty that practices sustainable and responsible energy management at UTEM.